Okay, so good afternoon. Feel asleep? So far so good.
Good.
But I saw for Middle America or South America student, I believe you don't have a lunch generally, because from my understanding you have breakfast, and then maybe afternoon you have a snack. Okay. Yes, and then later maybe 8 or 9 o'clock you have dinner. Am I right?
Yeah.
So do you still maintain this type of living style?
Yeah. It's different depending on who you are asking.
Okay. But I would like to know whether you will feel hungry in the afternoon. Still okay?
For me, it's fine.
But for Taiwan student, the class like right now is okay for you. I don't want you fall asleep quickly. Okay. But my personal preference is I prefer to complete my teaching job on Monday or Tuesday. So I will try to. And I also have master course, so also finished yesterday. So all my class is Monday. Mainly it's Monday or Tuesday. Maybe I will have some additional watch, but they are not consistent. Maybe only one semester or 2 semesters. Okay, so we keep on the class. Section 2.8. We apply force vector directed along the line. Okay, and this part of concept, we will apply what we learned yesterday, position vector. Do you still remember what's the position vector yesterday? So here we will use position vector concept for solving the question for the following part. Okay, so here, this example shown in this figure, a man pull on the cord with a force 350 Newton, represent this force acting on the support A as a Cartesian vector and determine its direction. Okay, we want to present this force using Cartesian vector and also want to know its direction. Okay, so force must be along this line. Okay, that's a cord and flexible. So if we can make it straight, that means our force must be along the line. Okay? So that's a condition. And then if we know force is along this line, so position vector can represent direction. Position vector, because for the cord we have 2 points. So these 2 points can give us position vector. So it represents the direction. Okay, then we have position vector work out from A to B. So we can quickly check from A to B. So we use B minus A. Okay, and if from B to A is opposite, we quickly check how it look like. So A from A to B. Okay, A here already shown. A is 12 because the height is from 3 to 15. So the difference is 12. But here show negative. Show negative. That means it's from A to B because we use point B minus point A. Point B is 3 and point A is 15. So A to B is 3 minus 15, so it's negative 12. Okay, so we know it's from B minus A. So for x-axis, B is 6, A is 0. So here is 6. Okay, then for y-axis, B is negative 4. Okay, Z is not Z. A is also 0. So we use negative 4 minus 0. Okay, then this part is 3 minus 15. So it's negative 12. So the position vector from A to B can be represented using this way. And its magnitude we can work out using this equation. Okay, so its magnitude is 14. So 14 that means distance. Okay, distance. Okay, and for a unit vector, we can use vector divided by magnitude. So we can work out unit vector. So vector divided by its magnitude. Okay, so unit vector can be worked out based on this formula. Okay, so we work out vector, not vector, we work out unit vector. Okay, so unit vector is here. Force represent using Cartesian system is scalar magnitude, okay, scalar times unit vector. And then we already know force scalar is 350. So times unit vector. So we can represent force vector using Cartesian system. Cartesian system. Okay? And then we have unit vector here. So we can work out its direction based on angle. We have unit vector here. So we can work out direction based on angle. Okay, clear? They are the same as yesterday content to work out the direction. Okay, still remember the content learned from yesterday? Okay, we keep going. So we represent force using Cartesian vector. Okay, first part is done, and then we know the direction for a force. So second part is also finished. Okay, then next part is example 2.12, and the roof is supported by cable. So cable, remember from the description, cable is also flexible. So if something linked to cable, so its force must be along the cable direction. Okay, flexible part only provide tensile force. Okay, only tensile force. And then if the cable has force FAB, A is here, B is here, is 100. FAC, okay, from here to here is 120. Okay, determine the resultant force acting at A and express the result as a Cartesian vector. Okay, before dealing with this problem, we already know, by observation, we already know we have a magnitude and length from AB and AC. We also can work out position vector. And remember previous question, we have position vector, of course we can work out unit vector. And then we have magnitude times unit vector. So we represent FAB using Cartesian system, and also FAC can be represented using constant system, both them. So we have constant system. Remember, force can, if they are concurrent, we can plus together. So if they plus together, we can work out its resultant force. Okay, so check the procedure. For FAB, okay, so x-axis, x is 4. Okay, and then y is 0, okay, along the plane, and z, here is 4, but from point B minus point A, so here is negative 4. Okay, here, AB is point B minus point A. So for x-axis, B is 4, and A is 0. Okay, then they are along xz plane, so there is no y value. Okay, no y value. J disappear because along xz plane, so no y value. Okay, then for z is 0 minus 4. 0 minus 4. So we got negative 4 here. So for position vector AB can be represented using this way. Okay, its length work out from here. Then we have scalar times unit vector. Okay, so this part is unit vector. So we can represent FAB using Cartesian system. Then FAC follow the same procedure. We work out position vector first. So use point C minus point A. So this position vector is here. Okay, then work out its length. And we have length, we have vector. We can work out unit vector here. Times by scalar. So FAC also can be represented using Cartesian vector. So we have FAB, we have FAC, summation, both them plus together. So resultant can be represented using this. Okay, we check what's the requirement. We want to, okay, we just need to express the resultant force using Cartesian vector. Okay, so that's the answer. Present the resultant force using Cartesian vector. Clear? Okay. Next one. The force shown in the figure act on the hook. Express it as a Cartesian vector. Okay, so hook is from here to here. So direction is from A to B. Direction is from A to B. So actually, if we know A coordinate here, okay, and we also need to work out B coordinate here. Okay, how to work out B coordinate? A is relative simple because we can just observe from here. Okay, so for point B, X, here is a right triangle. So if 4 meter here, so that 5 meter here, so that means here is 4 meter, and here is 3 meter. So follow this right triangle. Okay. So if we know this pi is 4 meter, and we also know 30 degrees, so we can use sine and cosine to work out sine 30 degree is x value, and cosine 30 degree is y value. Okay, so we can work out x, y, z. Z can be observed from here, which is 3. So sine 30. Okay, x value is sine 30. Sine 30 is 0.5. 0.5. Okay, 0.5 times by 4, so which is 2. But direction is negative x. So here is negative 2. Okay, then y value is positive, but it's we use 4 times by cosine 30 degree, so which is this value. Okay, so we know point B coordinate. So AB we use point B minus point A to work out position vector. Okay, point B minus point A. Point B is here, point A is here. So this one minus this one. So first part we got negative 4. This one, negative 2 minus 2, so negative 4. Then this part, this value minus 0, so which is positive. Okay, then we have 3 meter minus 2 meter, so we got 1 here. Okay, so we got the position vector from A to B, and then we can work out its length. So this turn is unit vector. Okay, so we work out unit vector. Use unit vector times by scalar. Then we can represent our force using Cartesian system. Okay for you? Okay. Okay, then we start. Next section is dot product. And dot product apply to two vector. Okay, we work out its dot product, and then A is a vector, B is also a vector. And if dot product for it is scalar for vector 1 times scalar for vector 2, cosine theta. Theta is the angle between these two vectors. Okay, so we call as a dot product. Then dot product result is a value. So there is no vector anymore. Okay, no vector anymore, just value. Okay, I can tell you, I saw a few days ago, I discussed with my colleague because we are talking about some of the research knowledge using dot product. But even like our level, sometimes we still can make mistake to work out dot product in our computer because there are too many too many elements and too much information should be included in the computer, and sometimes we still will make mistake. Okay, because too many information for us. So here, I understand concept is not difficult, but you should be careful to work out the result because even like us, we will make mistake. So that means for fraction, you will make mistake more easily. Okay. Okay, dot product concept is here. Okay. You can think about cosine. Okay. You can think about if here is a right triangle. Okay, if I link to a right triangle here. So use how to say a okay, what I want to say is dot product have a meaning. It's like projection. So, you can imagine if we have right triangle here, so A cosine theta. Okay, if we only look at here, A cosine theta is like A have a projection to B. So the same, if right triangle here is B have a projection concept to A. So it has the meaning like this. Okay? Do you understand what I'm talking about? It's about your observation and your your eye observation to see some to represent a result using projection. Okay? It has this kind of meaning. Okay, then for the operation, law of operation, A dot B equal to B dot A because they are value. So we can work out like this. Okay? And for multiplication by a scalar, so if we times an additional value here, so this lowercase a can times to vector here and also times to vector b. They mean the same thing. Okay, then we follow distribution law. If we have a vector summation here, and we use A dot, a resultant vector, the result will be the same as we use A dot B first, and then plus A dot D, because resultant here still vector, and we dot together still become the value. Okay, so it follows those kind of concept in terms of calculation. Okay, as we mentioned before, A dot B equal to A value times B value then times 2 cosine theta. We use this concept and to find the dot product for any two Cartesian unit vector, keep in mind, it's a unit vector. So like I is already unit vector. Dot I is 1. Unit vector, its scalar is 1. Okay, its value is 1. So 1 times 1 times cosine 0 degree. So it's 1. Okay, then if we have two vectors perpendicular to each other, I and j is perpendicular vector. So it's 1 times 1 times cosine 90 degrees, so which is 0. So for dot product, we only need to work out the vector has the same direction. Okay? Because perpendicular direction will give us 0. Clear? Okay, then for relative complicated calculation, vector have 3 components, x, y, z. Okay, 3 components. So its dot product is, okay, we use ax. Okay, dot product, we use this one, dot, this one first. That's the first component. Okay, then the second component is use this, dot this. Okay, the third component is this one, dot this one. Okay, so we have 3 components here, also 3 components here. So we follow distributed law. So we can work out those components. Okay, then from what we learned here, only same direction can give us result, certain value. If they are perpendicular, they should be 0. So that means, like this one or this one, okay, those things, they should be 0. Because they are perpendicular to each other. Okay, I'm talking about this component. Okay, so finally, dot product for this can be represented using this, because other part is 0. And for the same direction, they are 1. They are 1. Okay, I, j, j, k, k, they are 1. So only those part left. Clear? Okay, that's a simple derivation. And remember, this one will be used a lot in this class. Okay, when we are working out dot product. Okay, maybe you feel confused. Why do we learn this? Do you feel confused? Why do we learn this? Okay, I can tell you, maybe in under relative simple class, undergraduate class, this kind of concept is rare to be used. But if maybe in the future you go to some selective course, that means not compulsory course, more advanced, and they will have more difficult, more complicated calculation. Okay, then those concepts will be applied. Generally, if in software, numerical software, maybe for undergraduate students, you are not easy to touch numerical software. But in numerical software, we use those to represent element force. Okay? And like car, they have so many elements. So each element, we use this to represent its force condition. Okay, then for some certain calculation, we'll need it. But in software, they already embedded the function in it. But its calculation concept is what you learn right now. Okay, and I'm not doing this kind of research, but I know some researcher and their research group, students will try to modify software. So if you don't know its working concept, your modification, of course, couldn't be correct. Okay, so you have to know this for prepare yourself for further advanced course if necessary. Okay, so follow that product. That product. Remember previous equation. Okay, that product represented like this. So we can use this relationship to work out other information. For example, if we know the vector, we already know the vector, but we don't know theta. We know vector, we don't know theta. Okay? So we can use this relationship to work out theta. Okay, because vector, we will, as I mentioned, we know the vector, so we can work out its scalar. Okay, so we can follow this to work out theta. Then you will think, why now we don't measure the theta directly? Okay, in two-dimensional problem, theta is easy to be measured, but in three-dimensional problem, okay, it becomes very complicated to measure. For example, if you see maybe like the tree have its branch, okay, then I ask you, you measure the angle between the main timber and to the branch. What's the angle? But if you can work out using vector, the angle can be easily obtained. Okay? So three-dimensional problem using Cartesian vector become very important, but 2D relatively simple. But concept, they are the same. Okay, special case, if A dot B is 0, okay, that means vector A and vector B is perpendicular. Okay? Okay, clear? It just use the previous equation help us to work out the angle between two vectors. Okay, that's a similar application. If we have a rod here, we have a structure element look like this. So we can use that product to work out angle for us. Okay? And because practically in civil construction side, okay, I believe mechanical is the same because car element is also complicated. So for civil construction side, sometimes in our analysis, we just know what's the direction we should install certain element. But how accurate it is depends on, and I should say we should exactly define loss value for labor. For few labor, when they are working out, I should say their construction can be done. They just follow the number. So we should clearly indicate what's the number for that. And then they just give us the correct installation. Okay, so generally, for civil construction side, we shouldn't expect the labor understand lots of theory. They just need to know how to do the construction. So give them number directly is important. Okay, I believe in your country is the same. Okay, so civil field labor, they don't have this kind of fundamental statics concept. Okay, they just need to know how to follow the number. And I believe most of you understand in Taiwan right now, semiconductor is very good. Okay? But do you know why semiconductor manufacturing is not easy to be copied by other countries? Okay, I give you some reason. First, to make semiconductor, of course, your technique must be good. Okay, technique, and also government support. Government support that means they give you land to build manufacturing. Okay, we are not talking about it. Generally, semiconductor must be very precise. Okay, but if you ask civil labor to do precise work, not easy, because they just follow the numbers. So in Taiwan, semiconductor labor, generally they have master or PhD degree, because they can pursue precision. So, for our Taiwan surrounding country, like maybe like Thailand or Vietnam or even Indonesia, they want to copy Taiwan experience. One of the importance is your labor quality should be rise. Labor to control the manufacturing procedure. Okay? So if quality labor number is not enough, so forget it. If you want to produce very high-tech manufacturing, is not easy. Okay, so I should say for the past few decades, Taiwan education, we create lots of quality engineer. Okay? Okay, then application to use that product has been shown here. If component of A here is a line AA power by. Okay, so you can see for vector A, it has a projection of A on the line AA, projection on the line AA. So I told you that product have a projection meaning. So we can use this relationship to find out the projection. Okay, so AA can be represented by A cosine. Okay, it's scalar. A cosine theta. That's A cosine theta. Yes. Here is vector because it's a ball vector. And here is scalar. Cosine theta also only a value. So scalar times by unit vector. So give the vector for AA. Okay, so AA is scalar can be represented using this. Okay, only A cosine theta. So AA we can work out using dot product A vector dot unit vector for line AA. Okay, so we can work out the AA scalar. Clear? So just use A scalar times cosine theta, which is AA value. Okay, so we use this relationship quite a lot I will feel civil use this concept probably much more than other area. So in civil, not just in civil, maybe even in computer science. So right now, you know, imaging processing is very popular. Do you know this? How about Taiwan student? No reflection. Imaging 就是影像处理的 imaging processing or imaging AI used a lot. Okay, so generally imaging, like you, I use you as an example. Okay, I look at you, this direction or this direction, they are different. So using imaging AI, they should consider this effect. Okay, your eye observation is different. So they AI training, okay, they should, or not just training, even prediction, they should reflect this kind of projection effect. Okay, then your simulation can be more precise and more vivid. Okay. And civil, where do we use it? Because we can have some stellar imaging, and then we look from the air and to see, okay, what's the underground. So it's kind of projection. So we use the concept. Okay, if value A is positive, that means the vector direction is the same as the unit vector. Okay, then if we got a negative value, that means vector direction is different from unit vector. This unit vector comes from how we define which way is positive way. Okay, depends on our definition. Anyway, if we work out a result is negative, that means opposite direction to our definition. Okay. So definition can be changed. Okay. Definition can be changed. Anyway, when we work out a result negative, that means result is different from opposite to our defined direction. Okay, then I saw that's the same formula. If vector AA is scalar AA times by unit vector A. Okay, follow this relationship. So A, you can imagine its resultant vector. So resultant vector, they are concurrent. So it can be AA plus A perpendicular. So its resultant is here. So that's where, this part is sharp here. So A perpendicular can be represented by A minus AA. Okay, A minus AA, so we can work out A perpendicular. And the same approach, we can also work out a cosine, theta value using this relationship. Of course, we have this relationship, so we know A perpendicular follow this relationship. Okay, and then follow Pythagorean theory. A perpendicular equal to A squared minus AA squared and square root. Okay. Because they have right triangle. Okay, the projection of cable force here along the beam can be determined by the first finding the unit vector. That define the direction. Okay, we use unit vector define this element. Okay, we define the unit vector, define the direction. Then we can apply the concept using a dot product. To work out F, cable force F, working on element, beam element, okay? Working on beam element. So we use this kind of concept. Okay, clear? That's the application. Just check whether it's a break time. Okay, take a 10 minutes break. Of the projection of the force F, and shown in here, and F have a scalar is 100 Newton, and here we have two axes. Okay, keep in mind these two axes is not perpendicular to each other. Okay, it can be happen in real world. No one choose because for our mathematical calculation. That's our experience. We just follow x and y axis, so they're perpendicular to each other. But in real world, they are not necessary. So if they are not perpendicular to each other, okay, we should apply different technique or different knowledge to solve our problem. Okay, then simple calculation for 2D. Okay, is simple. We can directly apply cosine or sine relationship to work out the result. However, as I mentioned previously, three-dimensional problem, we can't find a proper angle. Okay, so we use like dot product. Probably it's easier for us to work out those information. But anyway, for this question, we want to find a projection for U axis and V axis. Okay, to work out U projection, so we use U is here. So F cosine 45 degrees. So we got this result. Okay, then V is cosine 15 degrees. So we got this result. I believe this question is not difficult. Okay, so just follow the procedure we can work out. Okay, then complicated part, jump out. In three-dimensional problem, the same, you want to work out certain information. So we apply previous concept learned. The frame shown here, subject to a horizontal force. Okay, it already indicates the force is horizontal and give you its direction. Okay, because it follows y-axis, positive y-axis. So it's 300. 300 is scalar. Okay, determine the magnitude of the component of the force parallel and perpendicular to member AB. Okay, member AB is here. So already indicate member AB, that means the position vector for AB is important. Okay, could be AB, could be BA. Depends on, anyway, it shows the direction along this element. Okay, we need to work out the force parallel AB, that means this direction, and perpendicular, that means this direction. Okay, we look at the procedure. So for AB, from axis definition, X, Y, Z, and A is original point. Original point. That means its coordinate is 3, 0. Okay, 0, 0, 0. Okay, then B. Okay, from the distance shown here, X is 2, Y is 6, Z is 3. Okay, so all of them are positive. And from the vector shown here, they are all positive. So last means they use point B minus point A. Okay, point B minus point A. And its value comes from dimension here. Okay, vector divided by its length is scalar. So become univector. Univector. Okay, then force. We can use cosine theta to work out, but three-dimensional problem not easy to work out a theta, so we can use dot product. And dot product, we already know force vector is 300J, and unit vector has been worked out here. So its dot product is here. This here. And remember which component can give us value, which component give us 0. So the same direction give us value. Okay? So here is only J, so that means this part and this part must be 0. So we only need to work out this times this. So component is here. Okay, so 300 times by 0.857 give us force. Okay, force along AB dot product and projection parallel. So it should be parallel. And we check. Yes, parallel. Okay, then we have its scalar times by univector. Scalar times univector give us represent a force using Cartesian vector. Okay, so Cartesian vector can be represented like this. So here is the vector, the force vector parallel to AB element. Okay, then we use force vector minus parallel. Okay, give us perpendicular. This part comes from previous slide here. Okay, previous slide. Although it's two-dimensional, but it comes from here. Okay. So, come from here. We have original vector minus parallel, so give us perpendicular. Okay, then the magnitude for perpendicular vector can be worked out using this relationship. So give us 155 Newton. Okay, clear? Okay for you? Okay, further application, also three-dimensional problem. The pipe shown here, subject to force of F 80. Okay, 80 Newton, but force have this direction, and determine the angle theta between theta between force vector and pipe segment. So pipe segment is this one, and force is here, so angle is here. Okay, and also segment BA, and the projection of F along the segment. Projection F along this segment. Okay, along this. Okay, keep in mind to work out this angle. Okay, we go back to previous slide. Here, when we are working out theta, vector is concurrent, okay? Direction is these two vectors has concurrent situation to work out theta. So when we work out a result here, theta is here. So they must be concurrent. So that means our vector should follow the direction is from B to A, because theta is here. If we use A to B, is the other angle. Okay, clear? So the direction must be B to A. Okay, because theta is here. Okay, then we check the procedure. So position vector from B to A. Sorry, since I run out of battery. I only can use my hand. So still can change the slide, but run out battery. There is no light point. Okay, so position vector from B to A and B from B to A. So we use point A minus point B. Okay, point A has x is 0, y is y is 1, and z is also 0. B has x value is 2, y 3. Where z is negative 1. So from B to A, so it should be A minus B. So A minus B, B to A. So it's negative 1. Okay? So first one, B to A, negative 2, and 1. Okay? Then for force, is B to C, and point C is x is 2, y is 0, and z is 0. So B to C, B to C, 2 minus 2, 0, 0 minus 2. No. B to C, C. From B to C, x is 2, y. So 2. Okay, yes, correct. Okay, this part disappeared. Okay, then we have a position vector. We can also work out its scalar. Okay, you remember what's the scalar equation? Scalar equation is like this. Okay, so we can work out scalar. So we use the dot product is like A dot B equal to, we move this part to this side is AB cosine theta. Okay, so we follow this equation, we can work out cosine theta is this value. Okay, then we know cosine theta is this value, theta can be worked out. Okay, clear? And unit vector for position vector, unit vector for BA direction can be worked out from this part. Okay, because we know its scalar is 3. Okay, first line is unit vector. So we use force scalar times unit vector to represent this force using Cartesian vector. Okay, that's the top part here. Okay, then force vector dot unit vector BA, that means the projection, okay, to BA. Okay, so force F is projection to BA, this direction, can be worked out here. Okay, and its value is 59 Newton. F dot unit vector is 59. Yes. Okay, and then here is a checking. When we know 80 cosine, the angle we after, we also work out 59. Okay, then we have some practice question here. So I should click. Okay, determine the magnitude of the resultant force, Fr. F1 plus F2, and its direction. Measure clockwise. from the positive u-axis. Okay, positive u-axis is here. And then we want to work out its direction, measure clockwise from u-axis. Okay, so we want to know the resultant direction, and this direction should be represented using the angle clockwise calculated from u-axis. Okay, and from this case, you should observe the angle here is 75. So that means the angle here is 75. Okay, this part the same as this part. So that means U and V, they are not perpendicular. Okay, because we have 75 angle here. Clear? They are not perpendicular. Okay, and do you learn I believe you learn the cosine law and sine law. Okay? So this equation, because they are not perpendicular to each other, we should apply sine or cosine law. Okay? Because as long as they are triangle, okay, depends on the information, we can apply sine and cosine law. So for cosine law is, for example, we know this, we know the angle, we can apply cosine law. And sine law is the angle with its opposite side, the ratio. Okay, they should follow the same ratio. Okay, clear? Remember? So this question, we should apply this kind of concept. So I just quickly reveal the solution, solving procedure, but I will not solve for you. I don't have a calculator. Okay, so to work out this, we know this angle is 45. Okay, because here is 75. So we know it's 45, and that means we know the angle here. Okay? We know the angle here. And then we know the magnitude here. So that means so theoretically, so its resultant should be here. Okay? Its resultant. Okay. Resultant direction. But resultant is not this one. We don't know this. The direction is what we need to work out. Okay? So 4 is here. Okay, so that means we know here theta this angle is 75. Okay, we know this angle is 75. So that means this angle is 105. This angle is 105. Okay, because this plus this should be 180. Okay, so and it also means this magnitude is 6. So we have 4 here, we have 6 here, we have 105 here. We can work out this using cosine law. Do you agree with that? Okay, so we know the magnitude for the resultant force. Okay, then we know the magnitude. So we know this value, we know this value, we know this value, we know the angle here. We can apply the sine law to work out the angle here. Clear? Sine law to work out angle. And then we know to calculate from this part what's the direction. Okay, what's the angle for the resultant? So we just use the angle calculate from F1 and minus this angle, we can get the result. Clear? You can't feel? What's the problem? It's a break time already. Anyway, do you capture my solving procedure? Do you capture my solving procedure? We use the cosine law to work out this. Okay, then 3 sides, we know its magnitude, and we have one angle. So we can use sine law to work out the angle here. Angle between the resultant and this 4 kilonewton. So we know the angle here. Okay, for example, I remember this angle finally work out is 50 something. I can't remember. Okay, 50 something. So calculate from here, 50 something minus 45. So which is the angle for final solution? Clear? Okay. So apply cosine law first, and then apply sine law.
Can we not use the dot product?
Use what?
The dot product. Like
But we don't have x, y, z. Okay, because if we use dot product, we should define x and y. But this case we don't have x, y, and their interest is u axis. So if we define x and y, we also need to define what's the u axis. So it becomes more complicated. Okay, so we go to next. Resolve the force F1 into component acting along the u and v axis. Determine the magnitude of the component. So I'm thinking this question is asked if V is here and U is here. So we already know here is 75. So we have force 4 kilonewton here. And they want to work out four kilonewton. 4 kilonewton. So here is 30 degrees. Here is 45 degrees. So actually, follow this shape. And we have 30 degree, 45 degree here. So the set, this part is 105. 105. And this angle, we have 105 to 4. Use apply sine law. 105 sine 105 divided by 4. Okay? Because I remember sine law is the magnitude. Okay, maybe magnitude is A divided by sine alpha equal to B divided by sine beta. Right? And even they can be reversed for sine law. Okay? So sine beta equal to C divided by sine gamma. So for sine law, we have 105, we have 4 here. And then we have angle here. So lastly, we also can work out here. Okay? And we have this angle, we also have this angle. So we can work out here. So by applying sine law. Okay for you? Okay, next one, relative simple because they follow x and y axis. So of course, there is not just one solution. We can directly apply cosine or sine to work out each component. But for two-dimensional problem, more complicated is we probably use the Cartesian system to solve the result. They can give us the same answer. Okay, then this force system, we want to express each force following Cartesian system. So like F1, x, y defined by I and j. Okay, F1 only x direction. So it's 900 I. Okay, and F2, 45 degrees. So cosine is this way, x, and sine give us y value. Okay. Okay, then for F3, follow the ratio 3 to 4. So x direction is positive. 4 divided by 5 is 0.8. So 0.8 times by this value is x component, positive. But y component is downward. So it's negative. Negative. And 3 divided by 5 is 0.6. So 0.6 times by 650 is a y component, but negative. Downward is negative. Okay, then if we plus all force together based on Cartesian system, we can work out the resultant. Okay, but we need to know the counterclockwise angle. So we should follow the angle. How do we work out tangent? Okay, tangent. For example, tangent theta. Theta here is x. Okay, y divided by x. Tangent. So the set, if we work out the resultant force here, we have the x direction summation. Here is y direction summation. So we can work out theta. Okay, then here is a question determine the coordinate angle gamma. Where is angle gamma? For the angle gamma for F2. F2. Okay, F2. Coordinate angle gamma for F2 and then express each force acting on the bracket. Okay, this way. This one should follow previous equation. Okay, this one should follow this equation. Alpha, beta, gamma, okay, equal to 1. Okay, clear? Okay, we go back to check. Because for F2, we know the angle here with x-axis. We know the angle with y-axis, but we don't know the angle with z-axis. So that's a gamma. But they should be equal to 1. So based on this last equation, we can work out gamma. Clear? Okay, then the second condition is express the force acting on the bracket as the Cartesian vector. So when we already know what's the gamma angle and cosine alpha, cosine beta, and cosine gamma, they are unit vector for the force. So we use this value times unit vector, so we can express F2 using Cartesian vector. So the same, here we already know the angle. We also can represent the result using Cartesian vector. So we have F1 expressed using Cartesian vector, F2 expressed as a Cartesian vector as well. Plus them together. So they are the acting force on the bracket. Okay? Clear? Okay, then the final one. Oh, it's not the final one. But anyway, this question determine the magnitude and coordinate direction angle on the resultant force acting at point A. The same thing, we express these two forces using Cartesian system, plus them together. So it's a resultant force for point A. Okay, then for our final resultant force expressed as a Cartesian vector, we can also work out its scalar. Okay, so we can have a unit vector. Then we use unit vector each component, which is cosine alpha, cosine beta, and cosine gamma. We can work out the direction angle. Okay, then this one determine the projection of the force F along the pole. So we work out a position vector for this pole as well. So we can apply that product. Oh, we have position vector. So we can work out a unit vector for this. So we use force dot unit vector here, which is a projection force along the pole. Okay? So generally we practice the question look like this. It's just on time. Okay, so we finish chapter 2, and I will assign some question as an assignment. I will ask my TA to upload the question. So depends on which day we upload the question on the Moodle. You have 1 week to complete it for the assignment. Clear? Only 1 week. I don't accept delay submission. Delay submission, you don't need to submit it. And generally, we will set up the midnight. Okay, that means 11:55 p.m. 59 p.m. So after that, that's the other day. I don't consider it.
Can you please have a question related to the exercise?
Related what?
Related to the questions, the exercise. Question.
I saw for me every question they are similar. But the concept will be similar, but of course the question looks different. Okay? Anyway, I understand you are still fresh, but like me, I teach this subject several times. Also, I have experience. So generally, I observe the question, I can roughly know how to solve it. So the same, if you want to become better, not just calculation skill, you also need to think about when you face a problem, what the solving procedure can reflect in your mind, in your brain. That means you become better. Okay? See you next week.
Hãy subscribe cho kênh Ghiền Mì Gõ để không bỏ lỡ những video hấp dẫn.